Okay, welcome there. Let us use this JAMB question to understand the concept of equilibrium forces, or you can say resolution of forces, or you can say resolution of vector quantities. Hmm? So this question says the diagram above shows forces 4 Newton, 6 Newton, 10 Newton, and 8 Newton, which act at a point O, and that point is here O, which acts at a point O in the direction indicated. Calculate the net horizontal force. We should calculate the net horizontal force. So in this equilibrium of forces, this one is not has nothing to do with moment. Because when you're talking about moment, you're looking at the turning effect. There has to be a fulcrum. But here there is no fulcrum, and there's nothing moment has to do with this one. So this one is about being able to resolve forces, different forces acting at a particular point, being able to resolve it and know the total horizontal force acting there, the total vertical force acting there, and then being able to calculate the resultant force. Resultant force being that one force that equates all the forces acting together. Okay, so what the question says, we should calculate the net horizontal force. They didn't say we should calculate the resultant force. So what we are going to look for is the total force that is acting on the horizontal axis of this point O. So the total horizontal force. So now, if you can see, we have 1, 2, 3, 4 forces. You can see for this 8 Newton force, it's inclined at an angle 60 degrees. Now, it being on that angle 60 degrees means it has two components. It has the vertical component and also has the horizontal component. Why do I say so? If assuming this straight arrow line was a rope, and you are drawing the rope towards this direction at an angle with respect to this other one that is horizontal, you find out that a force being applied at this angle is moving. Assuming if this center O is to move, it will be moving both upward and also forward. So that means this 8 Newton force has motion, or has impact in both the vertical and the horizontal. So that's why if you want to calculate net force, you have to resolve the ones that actually have angles. Unlike these ones that are the angles are 0, like 10 Newton and this one 4 Newton. You don't need to really resolve it. Even though you want to resolve it, the resolution on the vertical axis will be 0, being that it doesn't have any component on the vertical axis. It has no effect, because you see the force is just acting directly on the horizontal left, or this one directly on the horizontal right. So if this center was to move with respect to these ones, it will just move horizontal. It will not move upward at the same time. So let's not talk much and start calculating. So we calculate the net horizontal force. So I'll use capital letter H to represent my net horizontal force, which equals to, now my horizontal force, there are many ways to do this, but the easiest way I would explain is this. If you total one of the laws of equilibrium, total force in one direction will equal total force in the opposite direction. That is one. Or if you use principle of, or you can say principle of moment, you say total upward clockwise moment equals to total anti-clockwise moment. So let me use the first one I defined. Total forces in one direction equals to total in the opposite direction. So now you see 8 Newton force, 10 Newton force, and 6 Newton force are acting towards the right direction. You see, so they are acting towards the right direction. So if you resolve them into their horizontal components, they will be adding up, not subtracting. So what this means is this: 10, you can just write 10 there because it has no vertical component. There's nothing to resolve. But if you still want to resolve it, it has no vertical component, it is purely in horizontal component. But if you still want to resolve it, that would be 10 cos 0, because the angle of this 10 with respect to where it is 0. So if you do 10 cos 0, that will still give you 10 because cos 0 is 1. So I will just write 10 here. Okay, let me just 10 cos 0. Okay, plus what's the next force on the right? This one that is 8 Newton. If you resolve that, that will be 8 cos 60. That will be 8 what cos 60, because its angle with respect to the horizontal is 60 degrees. Okay, so we resolve the next one to its horizontal. Assuming you were to resolve to the vertical, this cos would have been sine. Okay, so we continue. Resolve that of 6, that will be plus 6 cos 60, then minus the total force in the opposite direction. So if you check in the opposite direction, which is the left direction, there's only one force acting that side, and that is 4 Newton. You can write 4 here, even if you choose to say 4 cos 0, it's still the same thing, because the angle of this force here with respect to horizontal is 0, and cos 0 is 1. So when you process that, 10 cos 0 is 10. Now 8 cos 60. Cos 60 is 1 over 2, or you say a half. So that will be 8 times 1 over 2 plus 6 times 1 over 2. Okay, then minus 4. Minus 4. Okay, so this will be 10 plus 4. Of course, 2 divide 8 4 times. 4 times 1, 4. Plus 3. 2 divide that. Minus 4. 10 plus 4, 14 plus that, 17. Minus 4. That will now equal what? 13 Newton. So the total horizontal force equals to what? 13 Newton, which is option A. So we've answered this question. So assuming I now take the question further and now ask you calculate the net vertical force. Calculate the net vertical force. And that I will represent it by capital letter Y. How would you do that? Now, in the vertical, considering the vertical, you are looking at upward and downward. So what you have here is that upward force must equal, upward force, sum of upward force equals to sum of downward force. So now, however, you see this 4 Newton and this 10 Newton, they have no vertical component because their angle with respect to the horizontal is 0, and also the angle with respect to the vertical is 90. So if you resolve it, sine 90 is 1, so it won't have it. So 4 and 10 will not be in the same distance. So the only one that have a vertical component is 8 Newton and 6 Newton. However, if you still choose to incorporate these other horizontal forces in calculation, okay, let's incorporate it and see what will happen. Now let's consider the upward force. Okay, so this force, let's start with 10. 10 is neither up or down, so let's still put it there, 10. With respect to vertical, you will say sine 10 sine 0. The angle of this 10 with respect to this horizontal, because since you are doing with respect to horizontal, all of them will have to be this. So 10 sine 0 plus, you resolve that of 8 sine 60. Okay, even if you choose to add this other 4 here, it will still give you 0, which is still meaningless. Okay, but let me just write it. 4 sine 0, then minus the only downward force here is 6, minus 6 sine 60. So if you process that, this first one will cancel because sine 0 is 0, so 0 times 10 is 0. This other 4 one will cancel, so that's what I was saying. The 10 Newton and the 4 Newton will not go. So the cancel. So what you'll be left is what? 8 sine 60 minus 6 sine 60. Sine 60. Which equals to 8 times sine 60 is root 3, and 60 is root 3 over 2, minus 6 times root 3 over 2. Over 2. So this will be equals to 2, cancel that 4. You now have 4 root 3 minus 2, cancel that 3, minus 3 root 3. In the end, 4 minus 3 is 1. The answer will be root 3 Newton. So the net vertical force will be what? Root 3 Newton here. So assuming again, I further take the question further to ask. That's question I. Question number 3 under one question. Take the follow, then and now say calculate the resultant force. Calculate the resultant force. What would that? How would you do that? So this is how you're going to calculate the resultant force. Now you know that the total horizontal force H equals to 13 Newton, and the total vertical force Y equals to square root of 3 Newton. And then you have to calculate the resultant, R. That's one singular, the equivalence of these two acting at that point. The way we normally do this is we draw a right angle triangle. We draw this triangle where the vertical axis is represent H. We label it 13 Newton, and the horizontal is 13 Newton, and then the vertical is root 3 Newton. Square root of 3 Newton. So the total vertical force is root 3 Newton. The reason why I drew them to this direction is obviously the horizontal one will tilt towards the right because most of the forces act towards the right, and the vertical one will go towards the top because the top has the greater force. So this is it. So the resultant will be the hypotenuse formed by that right angle triangle. Here will be the resultant. So this is a right angle triangle. So you're going to use Pythagoras theorem to determine R, which is the resultant. So you have here 13 squared plus square root of 3 all squared. So that your R will be square root of what? 13 squared plus root 3 squared. Root 3 squared is 3 plus 3. So this will be equals to square root of 13 raised to power 2 is 169 plus 3, which equals to square root of 172. Square root of 172. And square root of 172 will be 13.114877 Newton. Of course, you are going to approximate that to 2 decimal places. So that will be 13.12. That is 13.1 to 13.11 Newton, because here is 4 not up to 5, so you can join it there. 13.1. So the resultant force R is 13.11 Newton. So this is how we analyze equilibrium of forces when they are more than 2 acting at a point. We analyze it, find out the sum of the horizontal force, sum of the vertical force, and the resultant forces. So you like, share, and you subscribe. Then for online classes, online tutorial, the link to my WhatsApp group is in the description. So you can join there and then book a session with me where you learn one-on-one from me. Alright, thank you. But the answer to the original question is 13 Newton. Thank you.